Hi, Seth here, and welcome to the channel. This video is a bit technical, and I will try and simplify it as much as I can and give you some tips and tricks as well. I wanted to make a unique character based on my colleague in Stable Diffusion. So, I played around and came up with this image generated in SDXL. And I was able to create multiple styles, like this art, inspired by the game Red Dead Redemption, or a Harley Quinn cosplay, even a Da Vinci style chalk drawing, a digital cyborg art, and I could do all this using the base SDXL checkpoint with my own trained Lora model. So let me show you how. Before I start, I want to thank the user, the 3D Sphinx, who requested this tutorial. It was a learning curve for me, but yeah, I managed to learn and train my own model and am here to make things easy for you. So I would not be using automatic 1111. For this tutorial, I will be using the Kohya UI. It works better, and there are certain parameters that enable you to train a model with a low VRAM GPU. If you are new and don't know what I am talking about and want to learn, I have a playlist on the channel named Stable Diffusion, which would be an excellent place to start. I will start with installing Kohya for Windows and won't be doing a collab tutorial. I have a 4090, so some of the settings are fine-tuned for the 24GB 3090 and 4090 cards. However, I will also tell you how to set it up with low VRAM. This is the GitHub page for Kohya UI. I will leave the link in the description. The first thing you need to do is scroll down the page for installation. The prerequisites for installing this are very simple. Install Python 3.10 and remember to tick mark at Python to path during installation. Next, you need to install Git. If you are on the latest version of Windows 11, then I don't think you need any separate install of Visual Studio Redistributable. If you don't have it, use the link to install. If you have an NVIDIA 3000 or 4000 series card, you need to install version 8.6 DLLs for the CUDA Deep Neural Network. So scroll further down and download the zip file from the link given. This will speed up the training process drastically. I have created a folder called Lora Training in one of my drives. I would be installing Kohya here. The first thing you should do is right-click and open a terminal. Then, paste the git clone command to clone the GitHub repository. Now, close the terminal. We need to extract the zip folder downloaded earlier and put it inside the newly created Kohya SS folder. Now go inside the Kohya SS folder, right-click, and open a terminal. Type in /setup.bat and press enter. This is just for the initial install and configuration. Later on, you can start Kohya by clicking the GUI.bat file in the main folder. Now type 1 and press enter. This will install Kohya. Here, go with Torch 2. Just wait for the installation. It takes some time. After the installation is completed, we need to configure Accelerate manually. You can use the up or down arrow keys and hit enter for selection. For the environment, select this machine. Now select No Distributed Training. Keep typing no until it asks you about the GPU ID. For the GPU ID, type all. However, if you are on a laptop, type 0. For the mixed precision, if you use an older NVIDIA GPU, select FP16 as BF16 is not supported. If you are on a newer GPU like the A100 or 3090 or higher, select BF16 as it offers better stability during training. And that's about it. Type in 5 to launch Kohya. There is no one formula or set of parameters that I can tell you to use. It all depends on what you are training the model for. For checkpoint training, you need thousands of images for your dataset. It is much easier to train a LoRa model based on a pre-existing checkpoint. In this tutorial, what I am going to do is train a character LoRa model based on the SDXL1 checkpoint. I will explain the most important things you need to know in the simplest possible way so it is easy for you to get started. Let's go to the LoRa tab first. The configuration file is a .json file that saves your parameters and settings. From the model quick pick, you can choose a model from the list. You can choose any checkpoint model downloaded from Civit AI by selecting custom. I would be using the SDXL VAE fixed checkpoint. I will leave the Civit AI link for the model in the description. For all models, either base or checkpoints fine-tuned over SDXL, you need to tick Mark SDXL model. Before we go into the parameters, we need to prepare the dataset. The instance prompt is basically a keyword that would trigger the LoRa. You can put anything here. For example, I am going to put here Control-Alt-AI. The class prompt, on the other hand, should define your subject or style. In my case, I am using a portrait image of a real person. So, I will put the class prompt as just woman. Training images are the most crucial part. Your trained model would be based on these images. Around 25 to 50 images would do for a subject or an object. You would want to go a little higher, about 100 to 150, maybe more for style. To be honest, I have not tried training a style yet. The important thing here is that the images are of one extension, whether PNG or JPG. They should all be in the same format. The ratio of the images doesn't matter. However, the images should be of very high quality. I mean, if you are taking images of a real person, the facial details should be sharp and clear. From my testing, if you do not get the desired results, it's primarily due to the lack of variety and the quality of these images. If you are training a real person, you should have different angles of the person. Again, it depends on what you want to do. In my case, I am just using the face. If you want the AI to generate a faraway image of the person, then it's better to have some full body length images in the dataset. The same goes for any subject, object, or even style. Say you are training a model for birds. Depending on whether you want one species or different species of birds, you should include the bird photos in all angles accordingly. Birds flying, doing other actions, still shots, and so on. Coming to regularization images, they should represent the subject, object, or style class. My style class is a woman. So, my set of regularization images should all be of women. There's one trick here. Since my subject has curly hair, it would be better if all my regularization images of women are with curly hair. How many regularization images do you actually need? Well, different people will say different numbers. However, from what I have tried and tested, it should be approximately 2 or higher than the training images. I cannot define a specific number. How do we generate these regularization images? Let me show you a simple and easy way to do it. Let's open Stable Diffusion. The best way to do this is to use the same checkpoint model to generate the regularization images. I will use a simple prompt, portrait photo of woman, curly hair, and generate the images in batches. I am creating 3 folders to keep things organized. The first folder will include the training images, and the second will be the regularization images. The last folder is the training directory. I already have the images ready, just copying and pasting them into the relevant folders. Coming back to Kohya, I will now select the respective folders. The repeat value represents the number of steps. In other words, it means how often each image is put in the VRAM for training. It would be best to be careful here because there is an epoch setting, which I will explain later. The total number of steps I found best for my case is somewhere between 1,500 to 3,500. For now, remember that I have 54 training images, and if I change the repeat to 50, it means 2,700 steps only for the training images. I also have to calculate the steps for regularization images as well. When regularization is used, multiply the steps by 2x. So it will bring the total number of steps to 5,400. Which I don't want. So instead, I will use 30 steps. I am calculating the steps because there is something called overtraining and undertraining the Lora model. I can only give you a reference range here because it actually depends on how you want to train the model, the quality, and the variety of images. It's about finding the perfect balance. You will lack the desired results if the model is over or undertrained. After selecting the relevant folders, click on Prepare Training Data. What this does is it creates folders in a specific format for the training. It puts the training images in this folder and renames it with the steps and the trigger words as defined. It does the same for the regularization folder. You should now click on Copy Info to the Folder tab. Everything is set correctly in the Folders tab. I will now rename the model, after which I will explain the parameters settings. I will explain only the essential settings you need to tweak before training your model. You get a wide range of presets to select from. We will ignore the presets for now. Let's start with the Lora type. I trained my model with the standard type. I don't have enough data as I have not done rigorous testing for each type. But feel free to experiment. I suggest starting with the standard type for now. The batch size is how many images you want to put into the training at once. I have tested this, and 2 is an excellent value to start with. A batch size of 2 will train 2 images at a time simultaneously. For character training, anything higher might give inaccurate results. This is because when different images are learned at the same time, the tuning accuracy of each picture drops. If you are training a style model, a higher value may give you better results. Again, this all depends on your dataset. For my dataset, I found the best results at value 1. Another thing to note here is that when you increase the batch size, it divides the total number of learning steps by the batch size. For example, my dataset has 3,240 trained steps. Increasing the batch size to 3 would result in 1,080 training steps. Also, the higher the batch size, the more VRAM is consumed. Take note of this if you are on a low VRAM GPU. 1 epoch is 1 cycle of learning. This includes the repeats and the batch size. For any Lora, 2 or 3 epochs are good enough. I just went with the default value again because when I increased the value to 2, the training steps were at 6840 and the results were inaccurate with my dataset. This is why I gave the range of 1500 to 3500 for the character training model. For Dream Booth checkpoints, these values are way higher. Save every n epochs will save the Lora model for each epoch number as defined. For example, say your epoch value is 12 and you define to save every 3 epochs. What will happen here is that Kohya will save the model file 4 times. This is an excellent way to test and compare the results at different epochs and use only the best model. By the way, you can easily test and compare these by using the XYZ plot under scripts in Automatic 1111. As mentioned earlier, if your GPU is compatible, go with BF16, otherwise, stick to FP16 for mixed and save precision. I have an AMD 7950X3D CPU. Input a value up to 70 to 80% of the number of logical processors you have. If you are training on an SDXL model, change the resolution to 1024 by 1024. The learning rate is a bit complex. It's the rate at which the Lora learns the dataset during a specific training run. Let me explain with a simple analogy. Say you are learning to ride a bicycle on a path with twists and turns and smooth stretches of straightness. The learning rate here would be the rate at which you pedal. If you pedal too fast, you might ace the smooth part, but when it comes to the twists and turns, you might crash or miss vital signs telling you which way to go. In the same way, a high learning rate would be that the Lora might miss details from the dataset. However, say you pedal very slowly, adopting a low learning rate. You would be safe, but reaching your destination could take a lot of time. In Lora training, the learning rate helps you find the just right speed for pedaling. Sometimes, you might need to pedal faster when the road is smooth, and other times, you might need to slow down for those tricky parts. This way, you can reach your destination safely but not take too long. Learning rates in Lora are basically written in scientific notions. I will explain how to calculate the exact decimal point in a bit. To understand it completely, you need to understand the learning rate scheduler and the optimizer, which I will explain in the end, but first, I want to talk about the text encoder and UNet learning rate. These two values are separate from the learning rate values. When you define them, they take precedence. The text encoder learning rate is usually set lower than the UNet learning rate. This is because the text encoder is a relatively small and essential part of the model, and training it too quickly can lead to overfitting. Overfitting means the model will perform well on the training data, but poorly on new data that it has never seen before. The UNet is a larger and more complex part of the model, and it is responsible for generating the image from the text embedding. That is why the UNet learning rate is set to a higher value than the text encoder learning rate. The default values are 5 times 10 to the minus 5th power for the text encoder and 1 times 10 to the minus 4th power for the unit. Calculating this in decimal points is very simple. Just follow what I am doing on the calculator. The standard text encoder learning rate for the SDXL training is 4 times 10 to the minus 7th power. In SDXL specific parameters, make sure no half VAE is tick marked. Now, to network dimensions. The default value is 8. During my research, I found out that 32 is also very good. However, after extensive testing and research, I highly suggest keeping the value at 128. For my dataset, it worked great. To put it in simple terms, let's say you are building a Lego model. The Lego bricks are like the network dimensions in Lora training. The more Lego bricks you have, the more complex and detailed your build can be. But it is harder to build. If you only have a few Lego bricks, you will be limited by the number of bricks you have. So, you may not get the design perfectly as you want, but it will be easier to build. Less pieces, less time. A higher value in network dimensions means you will have more control over the stable diffusion model, but it will be more difficult to train. A lower value means you will have less control over the model, but it will be easier to train. I decided to try 3 values, which were 8, 32, and 128. For me, 128 worked best, but I realized the hard way that there is a correlation to network alpha in the sense that the network alpha value is relative to the value of network dimensions. So, the first 4 models I trained were with the network alpha value of 1. Network alpha is referred to in technical terms as a dampener. It controls how much the Lora model is allowed to change the stable diffusion model at each training step. Dampening slows down the learning process. This prevents the Lora model from making too many changes to the stable diffusion model at once, which can lead to unstable results. The default value is 1, which is pretty low if your network dimension value is set at 128. I tried setting both values at 128 and got my desired results. So technically, if your dimensions are 128, you should keep the network alpha value at 32 or 64 to get more control results and then go higher up. If you set it at the same value as the network dimension, it prevents the dampening, but may result in uncontrolled results. In simpler terms, if the Lora has too much effect, set a lower alpha value relative to the dimension value. If the Lora has too little influence, set the alpha value closer to the dimension value or at the same value. I recommend ticking memory efficient attention if you do not have enough VRAM. I trained the model with this option ticked. If you are too low on VRAM, tick mark gradient checkpointing. In samples, you can write a basic prompt and define to save a sample image every n steps or every n epochs. It is expected for the sample to be weird in the beginning and then turn out fine at later stages as the model is learning. This would slow the training as it would have to generate sample images during the training process. You would want your model to understand your data set quickly and then decrease the learning rate gradually to pick up finer details. An optimal training process does involve a variable learning rate. Adafactor optimizes the learning rate according to the situation of the VRAM, and it pairs very well with the Adafactor optimizer. Constant does not change from beginning to end. Cosine has a very high learning rate, which decreases to 0 as the number of steps increases. Cosine with restarts is like a cosine curve, but then it hard resets and starts the process again from a high learning rate to 0 multiple times throughout the training. To define how often it does this, you can set the value in the LR number of cycles option. If the number of this option is 2 or greater, the scheduler will run multiple times during a single training run. The default is blank, which equals the value of 1. Linear is similar to cosine, but the reduction towards 0 is in a linear line rather than a curve one. Also, linear will start at the learning rate setting. Polynomial is way more intense than cosine, and you can set it so that it's hard to reduce to 0. I would use polynomial when the image dataset does not have many distinct features to be learned, and at the same time, it is more efficient than constant. There are 2 options for polynomial. 1. You can input a value in the LR number of cycles option. Like cosine, if the number of this option is 2 or greater, the scheduler will run multiple times during a single training run. The second option is the LR power. If you set the power to 1, then the scheduler has the same curve as the linear scheduler. For my dataset, I used constant with warm-up scheduler. It starts with a learning rate of 0 and gradually increases towards the learning rate set value during warm-up. And it continues to use that rate during training. The LR warm-up option is applicable when you select this scheduler. I went with 100% value here as I wanted to increase the learning at 100% of the steps during warm-up. By applying this method, it allows the model to learn the intricate details from your dataset. These details may be lost during training if the warm-up is too short. I found this perfect for SDXL base and character Lora training. The list of optimizers is vast. Use AtomW 8-bit if you are low on VRAM. It works great and is accurate enough. However, if you have the extra VRAM, go with the AtomW, which is 32-bit. Adafactor adjusts the learning rate appropriately according to the progress of the learning. When you choose Adafactor, the learning rate setting is ignored. If you go to Utilities, WD14 Captioning, there is an option for you to automatically caption a description for each of the images and save it as a text file. Now, it automatically captions the description as per the photo. However, you are supposed to fine-tune it manually. I have not done this for this tutorial because when training a real person, captioning is really not needed. However, for checkpoint training or other subjects or styles of Lora, you may need to do this process before starting the training. I want to show you a trick to get your max training steps before starting the training. Go to Data Preparation, scroll down, and click on the Print Training command. Then, check the command prompt. Here, you can see all the details and how Kohya calculated the max train steps. Let's start the training, and then I will show you how to use the Lora and a trick with the CFG scale. The training takes a long time. It goes way faster with Atom W 8-bit optimizer. Let's open Automatic 1111. I have inputted the prompt and settings. I want to show you how the CFG scale can be used here to fine-tune your character. Notice that I have to use the trigger word Control-Alt-AI woman to get the trained character. Also, the Lora with the wait one. After much testing, I found that the CFG scale of 14 gives me the best likeliness to the original trained character instead of retraining the model with different parameters. However, this is prompt specific. This is how I achieved consistent results across various themes and styles, as showcased in the video's opening. If I keep increasing the CFG scale, it will overdo the character. And if I decrease the CFG scale, the character won't be what I have trained in the Lora at all. The fact that this is happening means that the model was trained properly and not over or under-trained. Note that the CFG scale basically weighs in the prompt. And since the prompt uses the trigger word Control-Alt-AI, the weightage of that trigger word also gets weighed in. There are many practical business applications for training your own Lora. And this can stay within your company internally, or if you are a freelancer within your computer. From the gaming industry to fashion, conceptual art, product designing, interior designing, and medical imaging, to name a few, you can enhance productivity in your workflow by training your own Lora model. It's just a learning curve, and once you get the hang of it, you are set and done. I hope you found this tutorial and the tips helpful. We really appreciate all the likes and the subs. Thank you for all the support given so far. Until next time.